A plug-in hybrid enhances the conventional hybrid concept with a much larger battery pack that, like in electric cars, must be fully recharged using an external electricity source from your home, office, or public charging station. This greater amount of energy storage is like a larger gas tank. It allows for extended all-electric driving, between 15 and 55 miles depending on the model, and can significantly reduce fuel consumption. In fact, if you have a short commute and recharge nightly, you'll be running on electricity most of the time. Should you deplete the all-electric range, the car basically reverts to being a conventional parallel hybrid. Plug-in hybrids, also known as PHEVs, short for plug-in hybrid electric vehicle, come with an engine and a battery/motor combo, as self-charging hybrids do, but, as the name suggests, their batteries can be charged up from a socket, in addition to the batteries being charged by the engine and brakes. PHEVs have larger battery packs and more powerful motors than self-charging hybrids, allowing them to travel much further, 20 to 80 miles, depending on the car, and at higher speeds, 70 miles per hour and beyond. Plug-in hybrids tend to be a fair bit more expensive than self-charging models, though they can be very attractive to company car drivers thanks to favorable tax arrangements. Many different models of car are offered with plug-in hybrid technology. It tends to be offered as an alternative to conventional petrol or diesel power on everything from the relatively humble Volkswagen Golf, to the high-end Porsche Cayenne. Some supercars, like the McLaren Artura and Ferrari SF90 Straddle, use plug-in hybrid power in the name of performance. Plug-in hybrid vehicles, PHEVs, are designed to be able to use an electric motor and battery as their primary energy source. The ICE may run simultaneously or only be a backup coming online when the electric battery is running out of power. These tend to be the most expensive hybrid cars, and the potential fuel savings are highest. Plug-in hybrid cars also have the lowest emissions impact on the environment. You'll want to make sure there are charging stations available at home and along any longer routes you take so you can take full advantage of the electric motor and battery. Unlike pure EVs or conventional hybrids, plug-in hybrid electric vehicles, PHEVs, operate like a hybrid but can be plugged into a wall outlet or EV charger, too. Fully charged, they can run on mostly electric power for about 20 to 40 miles, depending on the vehicle, until they switch back to regular hybrid operation. Unlike regular hybrids, a PHEV may be eligible for federal tax credits. Considering that the average American drives less than 40 miles per day, that means that some drivers will be able to do most of their daily travel on electric power, as long as they plug in first, while reserving the gas engine for longer trips. However, because of the added weight of their larger batteries, motors, and onboard charging equipment, PHEVs tend to cost more and get worse mileage than a conventional hybrid once that electric charge has run dry. If you charge daily and have a short commute, you'd consume hardly any fuel. In all other situations your fuel consumption could be higher than the regular hybrid counterpart. A pure EV might be a better choice if you can charge at home and rarely drive long distances. As the name implies, this type of hybrid can be plugged into an electricity outlet to recharge its batteries, as well as being charged on the move. Effectively, plug-in hybrids, PHEVs, are a halfway house between conventional hybrids and full electric vehicles. Although they have a conventional engine, they also have larger batteries than regular hybrids and can drive longer distances on electric power alone, up to 50 miles in some cases. Plug-in hybrid benefits. Compelling from a tax perspective. Meaningful electric range can allow for zero-emission commutes. Behaves like an electric car when charged. Can manage motorways on battery power. Tech lends itself to performance or economy. Plug-in hybrid disadvantages. Expensive compared to SC hybrids and conventional petrol and diesel cars. Have to be plugged in regularly to make the most of them. Overall fuel economy poor if battery isn't charged regularly. Heavier than conventional cars. Plug-in hybrids have the potential to be even more efficient than conventional hybrids because a more limited use of the PHEV's internal combustion engine may allow the engine to be used at closer to its maximum efficiency. A study published in 2014 by researchers from Lamar University, Iowa State University and Oak Ridge National Laboratory compared the operating costs of PHEVs of various electric ranges, 10, 20, 30, and 40 miles, with conventional gasoline vehicles and non-plug-in hybrid electric vehicles, HEVs, for different payback periods, considering different charging infrastructure deployment levels and gasoline prices. The study concluded that PHEVs save around 60% or 40% in energy costs, compared with conventional gasoline vehicles and HEVs, respectively. However, for drivers with significant daily vehicle miles traveled, DVMT, hybrid vehicles may be even a better choice than plug-in hybrids with a range of 40 miles 64 kilometers, particularly when there is a lack of public charging infrastructure. The incremental battery cost of large battery plug-in hybrids is difficult to justify based on the incremental savings of PHEVs' operating costs unless a subsidy is offered for large battery PHEVs. When the price of gasoline increases from $4 per gallon to $5 per gallon, the number of drivers who benefit from a larger battery increases significantly. If the gas price is $3, a plug-in hybrid with a range of 10 miles 16 kilometers is the least costly option even if the battery cost is $200/kWh. Although quick chargers can reduce charging time, they contribute little to energy cost savings for PHEVs, as opposed to level 2 chargers. Disadvantages of PHEVs include the additional cost, weight, and size of a larger battery pack. The effect of PHEVs on greenhouse emissions is complex. Plug-in hybrid vehicles operating on all-electric mode do not emit harmful tailpipe pollutants from the onboard source of power. The clean air benefit is usually local because depending on the source of the electricity used to recharge the batteries, air pollutant emissions are shifted to the location of the generation plants. In the same way, PHEVs do not emit greenhouse gases from the onboard source of power, but from the point of view of a well-to-wheel assessment, the extent of the benefit also depends on the fuel and technology used for electricity generation. From the perspective of a full life cycle analysis, the electricity used to recharge the batteries must be generated from zero-emission sources such as renewable, e.g. wind power, solar energy, or hydroelectricity, or nuclear power for PEVs to have almost none or zero well-to-wheel emissions. On the other hand, when PEVs are recharged from coal-fired plants, they usually produce slightly more greenhouse gas emissions than internal combustion engine vehicles. In the case of plug-in hybrid electric vehicle when operating in hybrid mode with assistance of the internal combustion engine, tailpipe, and greenhouse emissions are lower in comparison to conventional cars because of their higher fuel economy. Since 2008, plug-in hybrids have been commercially available from both specialty manufacturers and from mainstream producers of internal combustion engine vehicles. The F3DM, released in China in December 2008, was the first production plug-in hybrid sold in the world. The Chevrolet Volt, launched in the US in December 2010, was the first mass-production plug-in hybrid by a major car maker. There were 1.2 million plug-in hybrid cars on the world roads at the end of 2017. The stock of plug-in hybrids increased to 1.8 million in 2018, out of a global stock of about 5.1 million plug-in electric passenger cars. As of December 2017, the United States ranked as the world's largest plug-in hybrid car market with a stock of 360,510 units, followed by China with 276,580 vehicles, Japan with 100,860 units, the Netherlands with 98,220, and the UK with 88,660. Global sales of plug-in hybrids grew from over 300 units in 2010 to almost 9,000 in 2011, jumped to over 60,000 in 2012, and reached almost 222,000 in 2015. The Netherlands, Sweden, the UK, and the United States have the largest shares of plug-in hybrid sales as percentage of total plug-in electric passenger vehicle sales. The Netherlands has the world's largest share of plug-in hybrids among its plug-in electric passenger car stock, with 86,162 plug-in hybrids registered at the end of October 2016, out of 99,945 plug-in electric cars and vans, representing 86.2% of the country's stock of light-duty plug-in electric vehicles. Key components of a plug-in hybrid electric car. Battery, auxiliary in an electric drive vehicle. The low-voltage auxiliary battery provides electricity to start the car before the traction battery is engaged. It also powers vehicle accessories. Charge port. The charge port allows the vehicle to connect to an external power supply in order to charge the traction battery pack. DC/DC converter. This device converts higher voltage DC power from the traction battery pack to the lower voltage DC power needed to run vehicle accessories and recharge the auxiliary battery. Electric generator, generates electricity from the rotating wheels while braking, transferring that energy back to the traction battery pack. Some vehicles use motor generators that perform both the drive and regeneration functions. Electric traction motor, using power from the traction battery pack, this motor drives the vehicle's wheels. Some vehicles use motor generators that perform both the drive and regeneration functions. Exhaust system. The exhaust system channels the exhaust gases from the engine out through the tailpipe. A three-way catalyst is designed to reduce engine-out emissions within the exhaust system. Fuel filler, a nozzle from a fuel dispenser attaches to the receptacle on the vehicle to fill the tank. Fuel tank, gasoline. This tank stores gasoline on board the vehicle until it's needed by the engine. Internal combustion engine, spark ignited. In this configuration, fuel is injected into either the intake manifold or the combustion chamber, where it is combined with air, and the air/fuel mixture is ignited by the spark from a spark plug. Onboard charger, takes the incoming AC electricity supplied via the charge port and converts it to DC power for charging the traction battery. It also communicates with the charging equipment and monitors battery characteristics such as voltage, current, temperature, and state of charge while charging the pack. Power electronics controller. This unit manages the flow of electrical energy delivered by the traction battery, controlling the speed of the electric traction motor and the torque it produces. Thermal system, cooling. This system maintains a proper operating temperature range of the engine, electric motor, power electronics, and other components. Traction battery pack, stores electricity for use by the electric traction motor. Transmission. The transmission transfers mechanical power from the engine and/or electric traction motor to drive the wheels. PHEVs work by combining a combustion engine with an electric motor so they can use gas, battery power, or a mix of the two to run. Plug-in hybrids have a larger electric battery and a different recharging system than traditional hybrid vehicles. Depending on the model, an average plug-in hybrid's range is anywhere from 10 to 30 miles per charge, with some models reaching nearly 50 miles using all-electric power. In comparison, a traditional hybrid battery might only power a car on full electric mode for a mile or two, or it might only use electric power for non-driving functions. When the battery in a PHEV runs out, the combustion engine takes over and provides several hundred additional miles of range using conventional fuel until you have the opportunity to recharge. Unlike a traditional hybrid, which can charge its smaller battery from the combustion engine and regenerative braking, the larger PHEV battery must be plugged into a socket to recharge. Depending on the car, a normal wall outlet can charge a PHEV in about 6 hours, while a dedicated, higher voltage outlet can charge a plug-in hybrid in about 3 hours. A very high voltage charger might do the job in as little as 15 to 20 minutes. Thank you for watching this video.